Hi, in this video we are going to talk about function templates. The idea of function template is to write a function once and then let the compiler generate codes for different data types whenever you need the same functionality for different data types. For example, sort function. You write the sort function once, and if you want to sort an integer array, you pass int as a data type and sort function sorts an integer array. If you want to sort a character array, you pass char as a data type, right? Other example functions can be search, linear search, binary search, which you would like to perform on different types of arrays. Not only different types of arrays, you might want to perform on different data types as well. For example, vectors in C STL. You would want to perform search in a vector in place of array. You would want to perform search in a linked list, which is implemented as list in STL. So there exist many function templates in STL which work for different data types, also work for different containers like list, vector, arrays in STL. We discussed one example of function templates in the first video itself. Here is another example. In this example, we are taking an array as an input and size of array as an input, and we are finding maximum element in the array. Now such functions are required for many types of arrays. You would like to find the maximum in integer array, floating point array, or maybe your user defined array where you have, for example, items and you want to find the item which has maximum price, right? So you just want to call the array max for those things as well. So we write function once and we can use it for any data type. So here, to define the function which can take data type as an argument, we write this line first. We tell the compiler that this is a function which is going to take data type as an argument. And there can be multiple data types as an argument. You can have type name t and then type name say u or something, right? Some more data types. So this t is actually just a variable name. You can give it any name, right? It's just a name. You can have multiple template types also, like t1, t2, t3 as well, right? So this code takes an array of type t and an integer variable, which is an integer for all array types, which is just the size of the array, and it returns the maximum element in the array. So maximum element has to be same type as array type. That is why we have return type as t. Now we create a variable result which also has to be of type t, because result is going to be an array element. We initialize this result as array 0, then we traverse for remaining elements. So that is how we find the maximum. We initialize the maximum as the first element of the array, and then we traverse through remaining elements, and if we find elements greater than current maximum, we update the maximum, right? That's what we do here. And finally we return the result. Here is an example use of this function. What are we doing in this function? When we want to find the maximum of an integer array, we pass int as a template parameter, right? So what compiler internally does, it creates a copy of this function with t being replaced by int. So when function is created which has int as return type, int as an array, int as a result, and this is simply created using the template provided by us. After calling for int, we call it for float again. So one more copy of this function will be created where t will be replaced by float, right? So float array, float return type, float result type. This function will have this form, right? And when you call for float, it will use that newly created function and will call that function, right? So what do you get as an output here? You will get 40 here, and what do you get as an output? You get 30.5. That's the maximum value in this floating point array. Please note that compilers can sometimes guess this data type, int or float, right? According to the type of array that you pass. But it's always a good idea to not to let the compiler guess, but clearly specify what is the data type of the array that we are passing. That makes the code more readable and avoids unpredictable results. In this example program, we talked about a template which is used to find maximum value as an array. This array can be of any data type. We just have to provide data type to the template. One interesting fact about templates is we can also pass values as parameters. For example, say due to some reason, we do not want this template function to process arrays of size more than a limit, and this limit might be compiler specific and user would like to provide this limit, right? So what we do, we add an integer parameter to the templates, right? Say we have a parameter int limit, which is limit of the array that you are passing, limit on the size of the array. So what we can do is we can add a condition here. If n is greater than limit, then do some error handling, right? Maybe throw an exception or return some value, specific value, which means your array size is having size more than the provided limit. Now we know how do we pass the data types. The question arises, how do we pass non-data type parameters? We can simply pass them as we pass the data types. For example, I can pass the limit as 100 here, and I can call the same function the same way, 3. So this function now works the same way. It is just that it has an integer parameter also. Similarly here, I can change it and provide a limit for floating point numbers. If 50 is the limit for floating point numbers, I can call array 2 and can pass for this array 4, right? So this limit parameter is an integer parameter, it's not a data type, and it is processed by the templates. One interesting fact about the non-data type parameters, when you are passing a value, it has to be a constant value because it is going to be processed by the compiler. You know it, right? When you write these templates, at the compile time, these functions are generated. So your compiler should know the value of limit so that it can generate the appropriate code. It can pass, replace this limit with that limit that you have provided. So this has to be a const parameter. So if you say, for example, put x equal to 100, right? Int x equal to 100, and if you try to pass x here, you will get error because this is not a const value. But if you replace int x with constant x, then this function will work because now it's a const value and compiler knows the value of this x. So the fact is, we can pass non-data type parameters as well, but they should be having a constant value so that the appropriate code can be generated by the compiler. In this video, we talked about function template. We mainly discussed an example, and we also talked about non-data type parameters. In the next video, we will be talking about class templates.